What is a tornado? Tornadoes are defined as a column of air that are violently rotating and stretches from the cloud of a thunderstorm all the way down to the ground. It is actually condensation from water vapor that has been mingled with dust and debris that has been pulled up from the surface. This is what we see for the funnel. Tornadoes can be small and feeble, lasting only a few minutes, or they can evolve into enormous monsters that are a mile wide and continue for more than an hour on average. Strong enough to level entire towns, the winds that blow inside can reach speeds of up to more than 200 miles per hour and can range from 65 miles per hour. The key ingredients for tornado formation: tornadoes can only form when the perfect combination of weather conditions is present. The process is frequently compared to making a cake, in which case you need to have all of the necessary ingredients. The first component is air that is warm and humid and is located close to the surface. This air typically originates from places such as the Gulf of Mexico in the United States. Secondly, there is air that is cold and dry, which is located higher up in the atmosphere. This air typically comes from the Rockies or Canada. As a result of the collision between these two air masses, the atmosphere becomes unstable. Adding in high wind shear, which is defined as the change in wind speed and direction with height, results in the formation of rolling tubes of air that are not apparent to the naked eye. A lifting mechanism, such as a cold front or a dry line, is required in order to initiate the development of thunderstorms. This mechanism is responsible for pushing warm air higher and pushing it upward. Supercells, the storms that spawn tornadoes. It is possible that tornadoes will not occur as a consequence of certain thunderstorms. The storms that are most likely to be produced by persons are referred to as supercells, and these are the storms that are described as being of this type. The structure of a supercell is characterized by a powerful updraft and rotation, which contributes to the fact that it is a big thunderstorm that rotates. A mesocyclone is a sort of spinning updraft that is generated as a result of wind shear, which causes the invisible horizontal tubes of air to be tilted into a vertical position. This causes the mesocyclone to spin. The formation of a mesocyclone is the consequence of this scenario. In the absence of this rotation, the storm will not be organized in a manner that is sufficient to concentrate its energy into a tornado. Therefore, it is of the utmost importance that this rotation takes place. Supercells are responsible for the most intense and catastrophic tornadoes, although they are exceedingly uncommon in contrast to other types of thunderstorms. Supercells are the storms that are responsible for the most intense tornadoes. Step 1. Wind shear creates rotation. The initial phase of this process is the wind shear, which is the first step in the process. When compared to the winds that blow higher above, the winds that blow near the ground may originate from the south at a slower pace. On the other hand, the winds that blow higher above may originate from a different direction, such as the west, and may blow at that speed even though they begin from the south. This discrepancy causes the development of horizontal tubes of rotating air that are not visible to the naked eye when they are in proximity to the surface. In the vast majority of cases, they continue to remain in that state and never experience any issues as a result of their existence. These rolling tubes, on the other hand, can form the foundation for something that is far more substantial if the ideal storm arises. Step 2. Updrafts tilt the rotation. When warm, moist air rises into a thunderstorm, it creates a strong updraft. This rising column of air tilts the horizontal tube of rotation into a vertical position. Instead of spinning sideways across the land, the air begins to spin upward into the sky. This vertical rotation is a critical step toward tornado development. Step 3. Mesocyclone formation. Once tilted vertically, the rotating air becomes more organized and concentrated. This is known as a mesocyclone, a rotating updraft within the supercell thunderstorm. Mesocyclones can be several miles wide, and while they don't always produce tornadoes, every strong tornado starts here. Step 4. Rear flank. Downdraft tightens the storm. As the storm matures, cool air descends behind the mesocyclone in what's called the rear flank downdraft. This sinking air wraps around the circulation, tightening and focusing it. Think of it like spinning a top. When it's concentrated in one place, it spins faster and more powerfully. Step 5. Funnel cloud development. At this point, the rotating air lowers from the storm cloud. As pressure drops in the center of the circulation, air cools and condenses, forming the classic funnel cloud. This funnel is often the first visible sign that a tornado may be forming. However, until it actually touches the ground, it's not yet considered a tornado. Step 6. Tornado touchdown. In order for the funnel cloud to be considered a tornado, it must first make contact with the ground and then start to accumulate debris. These two steps are necessary for the tornado classification. In this vantage point, it is conceivable for it to become more strong, wider, and destructive, depending on the energy and surroundings of the storm. This is because it is feasible for it to occur. This is determined by the environment that the storm is existing in. Some tornadoes continue to be extremely thin and rope-like, while others grow into giant wedges that have the appearance of enormous walls of air that are whirling. Both types of tornadoes are characterized by tremendous rotation. This is due to the fact that certain tornadoes continue to increase in magnitude. Why some tornadoes are stronger than others. The strength of a tornado can vary based on several parameters, including the strength of the updraft, the amount of wind shear that is present, and the length of time that the storm remains structured. It is the Enhanced Fujita Scale, sometimes known as the EF scale, that meteorologists use to measure tornadoes. Tornadoes with an EF0 rating are only capable of causing damage to trees and roofs, whereas tornadoes with an EF5 rating can destroy entire buildings, hurl vehicles, and remove pavement from roadways. The amount of energy that the storm is able to channel into the revolving column of air is the variable that determines the difference. Tornado geography. Why the US sees the most. In spite of the fact that tornadoes can be found in any part of the world, from Argentina to Bangladesh, the United States of America is the country that experiences the most number of tornadoes on an annual basis, with more than 1,000 of them occurring yearly. There is a possibility of tornadoes occurring in Bangladesh. Geographical evidence suggests that this is taking place, which is the reason for this phenomena. At the Great Plains, the warm, humid air from the Gulf of Mexico collides with the cold, dry air from Canada and the dry air from the Rocky Mountains. This is a region where the Great Plains are formed. If the Great Plains were a mixing bowl, then this would be the case. Because of this, a wide range of different weather patterns are formed as a result. As a result of its one-of-a-kind configuration, the region in the middle of the United States that is widely referred to as Tornado Alley is considered to be the central location for tornadoes by people from all over the world. The unpredictable nature of tornadoes. The ability to accurately forecast when and where a tornado will form is still difficult to achieve, even with the advancement of technology. Meteorologists can't predict the specific storm that will produce a tornado, but they are able to identify conditions that are conducive to tornadoes and issue precautionary watches. While there are supercells that can spin for hours without producing a single tornado, there are also supercells that can produce many twisters in rapid succession. Due to the fact that they are unpredictable, tornadoes pose a significant threat. If you enjoyed this breakdown, make sure to hit the like button, share this video, and subscribe for more science explained in simple terms. And let me know in the comments, would you ever chase a tornado, or would you rather watch safely from your couch?